Hey everyone, I want to go over a couple of the important concepts in Unit 2 so that you make sure that you understand the directions and the type of solution for each question that you see. On your review, you will see this graphic organizer, and what I want you to do is I want you to take a few minutes and I want you to think about the 5 types of equations and inequalities and think about what the solution would be like. Maybe what the problem, what format it might be in, and then how you would represent that either on a graph or a number line. So take a few minutes to do that now, and then come back and join me, and we'll look at each one separately. All right, so the first is a one variable equation. Think of this as just your regular equation that you're used to solving. You started solving these in middle school. So an example would be 3x plus 5 equals 14. We would use the properties of operations to solve this equation by subtracting 5 and dividing by 3. Our solution then is x equals 3. It's a number. It's the one number that makes it true. Now, it is possible to have no solutions or all real numbers. We typically don't see that. So typically we see a 1 point. If we were going to put this on the number line, we would just put a closed circle at the number 3 to let everyone know that 3 is the only number that can make that equation true. Then we went to one variable inequalities. So the difference between an equation and an inequality is an inequality has a solution set. So you can see here, I changed my problem to 3x plus 5 is less than 14. I would use the same procedure to solve it, but now our solution is x is less than 3. So that means that any number smaller than 3 will make this inequality true. So we represent that on a number line with an open circle at 3, saying that that's our boundary but not included, and then every number to the left or less. So remember, when you're graphing these on a number line, if you have a greater than or a less than, it's an open circle. And if it's a greater than or equal to, less than or equal to, it's a closed circle because you want to include that point. Next, we went to two variable equations. Here you have two different examples. Y equals 2x minus 3, which is in slope-intercept form, or 4x plus 5y equals 20, which is in standard form. The solution is all the ordered pairs that make the equation true. So when you plot all of these ordered pairs together, they end up making a straight line. Now when you're graphing, there are two different methods. Slope-intercept form is what you're used to, like y equals 2x minus 3, where you would begin on the y-axis at negative 3, and then you would use your slope of 2 to move up to right 1 or down to left 1. That would have a positive slope, so it would go up to the right. Or if it's in standard form, you can either rearrange the formula like we did back in Unit 1 so that it's in slope-intercept form and solve for y, or you can find the x and y intercepts. Remember, the x-intercept is when you plug in 0 for y and you solve for x. The y-intercept is when you put 0 in for x and solve for y. Most importantly, remember that the x and the y-intercepts are two different ordered pairs. So once you plot these two ordered pairs, you can graph your line. Then we went to two variable inequalities. So the only difference between the equations and the inequalities when you see it is it's going to have a greater than or equal to, less than or equal to sign. If the inequality is a greater than or less than, you're going to have a dotted or dashed line to let you know that that's the boundary, but it's not included in the solution. If you have a greater than or equal to, less than or equal to, it's going to be a solid line to indicate that all of the points on the line do make that inequality true. And then don't forget to shade. You can see here that I have a line and kind of a weird looking shading because I'm not on a coordinate plane. But don't forget to shade for an inequality. So the solution is all the ordered pairs that make that inequality true. So that's shown in the shaded part. And then again, remember, the line is sometimes included if it has an equal sign. The last type of thing that we did was system of equations. This is when you have two equations, or you could have more, and you find out where both equations are true. Usually that's an ordered pair. So as you can see on this diagram right here in the circle, these two lines intersect at one spot. So the ordered pair x, y would be the solution. It's the one ordered pair that lies on both lines. If your lines are parallel, then there's going to be no solution. If they're parallel, they have the same slope but different y-intercepts. Since they never share a similar point, then there's no solution. And then you have infinitely many solutions, which looks like one line, but it's really one line graphed upon another line. And that means that they intersect at every single point. We call that infinitely many solutions. There are three ways that we've learned how to solve systems of equations. The first is by graphing to see where they intersect. The second is substitution. And the third is elimination. All three methods work for every problem, but be careful to choose the right one for the appropriateness of that problem. So here's my completed graphic organizer to kind of help me remember what my solution will look like. If you understand what the question's asking, then you'll be able to answer it in a more efficient way. Also, please make sure that you know these key terms and formulas. Make sure you know what they mean, how to find them, and how to use them. And lastly, as you're doing this review, I want you to find a quiet place to work, and you do everything that you can first. You might want to highlight the verb or the question so you know what you're looking for. Restate what the directions are asking for in your own words so that you know when you're done. Decide on your method or strategy to solve the problem, and then check to make sure if your answer makes sense. We often forget to do this, but it's a good idea to remember to do that. You can write on the review or your own paper. And then, if you're still struggling with specific topics, more practice can be found at bit.ly/ACC Unit 2. It is case sensitive, so make sure you type it in exactly as you see it. All right, good luck on the rest of your review, and make sure you refer back to this graphic organizer if you're not sure what the directions are asking for.